Hi everyone, welcome to our first class on nutrition. Before we dive into the core material, let's start with a refresher on the digestive system. A process you've already learned in your anatomy and physiology courses, but one that will be critical as we explore how nutrition supports wellness and overall health. Whether you're a nursing student or just curious, this detailed breakdown will give you a clear understanding of how our body processes food. Digestion starts even before you eat. The smell or sight of food can trigger salivation, a signal that your body is preparing for digestion. When food enters your mouth, you begin to chew, breaking it down into smaller pieces. This process is called mechanical digestion. Your saliva contains enzymes like amylase, which starts breaking down carbohydrates into simpler sugars like maltose. While this is just the beginning, it plays an important role in making it easier for your body to absorb sugars later in the digestive process. The teeth and tongue work together to mix food with saliva, forming a soft mass called a bolus, which can be easily swallowed. Once swallowed, the bolus travels down the esophagus through a process called peristalsis, which are rhythmic contractions of smooth muscles. This pushes the food down toward the stomach. The esophagus doesn't digest food, but acts as a passage. The bolus passes through the lower esophageal sphincter, a valve that opens to let food into the stomach and closes to prevent acid reflux, which occurs when stomach acid leaks back into the esophagus. Now in the stomach, the real chemical digestion begins. The stomach's main role is to churn the food and mix it with gastric juices. Gastric juices contain hydrochloric acid and the enzyme pepsin, which together begin breaking down proteins into smaller peptides. HCl not only creates an acidic environment ideal for pepsin, but also kills harmful bacteria. The stomach also produces intrinsic factor, which is crucial for absorbing vitamin B12 in the small intestine. Without intrinsic factor, your body wouldn't be able to absorb this essential vitamin, leading to conditions like pernicious anemia. By the time the stomach is done churning food, the bolus has turned into a semi-liquid substance called chyme, which is ready to move to the small intestine. The chyme moves into the small intestine, where most of the nutrient absorption takes place. The small intestine has three parts: the duodenum, jejunum, and ileum. In the duodenum, the chyme is mixed with bile from the gallbladder and digestive enzymes from the pancreas. These enzymes include amylase, lipase, proteases like trypsin and chymotrypsin. Bile, produced by the liver and stored in the gallbladder, helps emulsify fats, making it easier for lipase to digest them. The pancreas also releases bicarbonate to neutralize the acidic chyme, protecting the lining of the small intestine. After the duodenum, the chyme moves into the jejunum, where most of the nutrients, including carbohydrates, proteins, and fats, are absorbed into the bloodstream. Finally, in the ileum, absorption of remaining nutrients like vitamin B12 and bile acids occurs. The liver, gallbladder, and pancreas play critical roles in digestion without being directly involved in the breakdown of food inside the intestines. The liver produces bile, which helps break down fats, and also filters toxins from the blood before it enters the digestive system. It stores and releases glucose as needed, helping regulate blood sugar levels. The gallbladder stores bile and releases it into the small intestine when fats are present in the chyme. The pancreas releases digestive enzymes, including amylase, lipase, and proteases, and produces insulin, which helps regulate blood sugar levels by moving glucose from the bloodstream into cells. For people with diabetes, the pancreas may not produce enough insulin, leading to poor regulation of blood sugar. After most nutrients have been absorbed, the remaining waste moves into the large intestine. The large intestine's main function is to reabsorb water and electrolytes like sodium and potassium, helping maintain balance in your body. As water is absorbed, the waste becomes more solid and forms stool. The bacteria in the large intestine also help break down any remaining nutrients and produce vitamins like vitamin K. For people with kidney issues, maintaining electrolyte balance can be challenging. If your kidneys can't filter out excess potassium, for example, it could affect how well your digestive system functions, leading to symptoms like nausea and constipation. Finally, the waste is stored in the rectum until it is eliminated from the body through the anus during defecation. This is the last step in the digestive process, where the body gets rid of what it no longer needs. To sum up, digestion is a complex process that involves multiple organs and enzymes, all working together to break down food, absorb nutrients, and eliminate waste. Whether you're dealing with a condition like diabetes, where blood sugar regulation is key, or kidney disease, which affects electrolyte balance, understanding how your digestive system works is crucial to maintaining overall health.